In this video, I'm going to discuss ions and ionic bonds. An ion is an atom or molecule with a net electric charge due to the loss or gain of one or more electrons. The net electric charge means the total charge. Some ions are positively charged. An example would be a sodium ion, or Na+. The loss of an electron gives a sodium atom a net positive charge of +1. Let's see how this works. So if we go to the periodic table, we see that sodium has an atomic number of 11, meaning that it has 11 protons. To be electrically neutral, an atom of sodium would have to have 11 electrons. So let's take a look at the sodium atom. We see that the way that if we look at the distribution of the electrons, in the innermost shell there are 2 electrons. In the next shell, the middle shell, there are 8 electrons. And in the last shell, the most outermost shell, there's just 1 electron. Now the rule was that I've given before in previous videos is that for an atom to be electrically stable, it should have 8 electrons in its outermost shell. In this case, sodium has only 1 electron in its outermost shell. One possibility is that sodium could gain 7 electrons. That would be quite difficult, so an easier route for sodium is to lose an electron. So if it gives up or donates an electron to another atom, it then becomes an ion. However, now it has 8 electrons in its outermost shell and it's more stable. So why does it have a charge of +1? Well, sodium started with has 11 protons, and it starts with 11 electrons. It's electrically neutral. However, if it gives up one of its electrons, now it'll have a positive charge of +1. So some ions are actually negatively charged. An example is a chloride ion, or Cl-. The addition of an electron gives a negative charge of -1. So let's see how this works. Well, if we go to the periodic table, a chlorine atom has an atomic number of 17, meaning it has 17 protons. This means to be electrically neutral, it should have 17 electrons. So let's see how the electrons are distributed. It has 2 electrons in the innermost shell, 8 in the next shell, so that's 10 electrons so far, and then it has 7 electrons in the outermost shell. So what chloride needs to be stable is to have 8 electrons in its outermost shell, so it needs to gain 1 electron. So if another atom donates 1 electron to it, it will now have a complete outermost shell with 8 electrons. However, it will have gained 1 electron, therefore it will have a charge of -1. And just to remind you, there are other possibilities. Some ions may have gained or lost more than 1 electron. So for example, calcium ion is actually Ca2+, meaning it has a charge of +2. So why is this important? Well, ions themselves are very important. You have a lot of ions in your blood, which we'll discuss later on. However, another reason this is important is that ionic bonds can form between oppositely charged ions. An ionic bond is formed when oppositely charged ions are attracted to one another. For example, sodium is +1, chloride is -1. When they combine, they form sodium chloride, which is electrically neutral. So how does this work? Well, remember our sodium ion, Na+? Well, it has, it's stable in the sense that it has 8 electrons in its outermost shell. It does have a charge of +1. Chloride, the chloride ion, is Cl-. It has a charge of -1. It's also stable in the sense that it has 8 electrons in its outermost shell. Now, in this type of bond, the electrons are not actually shared the way they are in a covalent bond. However, there's a very strong attraction between an atom that is positively charged and an atom that is negatively charged. Therefore, sodium and chloride are very strongly attracted to each other, and therefore they can bond in this way. So this is called an ionic bond. Now, ionic bonds are weaker than covalent bonds because electrons aren't actually shared, but they can be relatively strong. So NaCl is in fact table salt. That's quite, if you pick up a grain of salt, you can feel it's quite tough, right? So and that's an indication that there are strong ionic bonds between the sodium and chloride. However, if you put table salt into water, then the ionic bonds are much weaker than covalent bonds. And the reason for this is because the sodium and chloride will mostly dissociate, meaning it will break apart into individual sodium and chloride ions in the water. And what will happen is the water molecules, which are polar, will essentially end up surrounding the sodium and chloride, and this helps with this process of dissociation. Now, it is possible occasionally for some sodium and chloride ions to reassociate within the water, so there is some of that going on. But for the most part, the sodium and chloride are dissociated. Now, this is actually important in medicine, and we're going to be talking a lot about your health and so forth in this class. So you've probably heard the term electrolytes. So this refers to a solution in which you have ions. You have ions in an aqueous solution. These are called electrolytes because they make the solution a good conductor of electricity. And the electricity is conducted not as electrons, but as in the movement of these ions. So that's where the term electrolyte comes up. And of course, you've probably heard it. Like if you're dehydrated and you're doing some sort of sport, you've often been told you should drink a drink with electrolytes in it, such as Gatorade or some other Pedialyte's another one. There's a bunch of these different drinks out there that help with dehydration. So they hydrate you, but at the same time, they also replace these ions that are so important for good health. Okay, so we're going to stop there. In the next video, we're going to talk about yet another type of bond